Hello, in this video we're going to learn how to find the derivative of an inverse function, and we'll look at several different kinds of inverse functions. The first inverse function we're going to consider is g of x equals the natural log of x, and this is of course the inverse of y equals e to the x. So let's derive the formula for the derivative of the natural log of x. So ultimately here we want to end up with g prime of x. That's what we're trying to discover here. What is g prime of x if g of x is the natural log of x? Let's start by exponentiating both sides. So that's going to give us e to the power g of x equals e to the power natural log of x. And we can use our log properties to simplify this. E to the power g of x equals x, because e to the power ln x equals x. Now we know how to find the derivative of an exponential function. That's one of the rules we've already looked at. So now and we know how to take the derivative of x on the right-hand side of the equation using our power rule. So let's go ahead and take the derivative now of both sides of this equation. So we're going to take the derivative with respect to x of e to the power g of x, and we'll take the derivative with respect to x of x. So on the left, the derivative of e to the power g of x, we're going to use the chain rule here, is e to the power g of x times g prime of x. And on the right, the derivative of x with respect to x is just 1. Now remember the goal. We are trying to solve for g prime of x. So let's isolate that g prime of x on one side of the equation. So we have g prime of x equals, we're dividing both sides by e to the power g of x, so 1 over e to the power g of x. And we know that g of x is equal to ln x, so let's make that substitution. We will replace g of x with ln x. And using properties of logs, we can simplify that, because e to the power ln x is just equal to x. Okay, so we have found that g prime of x, which is the derivative of ln x, is equal to 1 over x. So this is our next derivative rule to memorize. The derivative of the natural log of x with respect to x is equal to 1 over x. Now if we have the natural log of anything other than x, we're going to need to use the chain rule. So in general, if we want to find the derivative of the natural log of u with respect to x, that is going to equal 1 over u times du dx. Or in other words, if we want to find the derivative, if we have the natural log of stuff, the derivative of that is going to be 1 over the stuff times the derivative of the stuff. Let's look at some examples. The derivative of the natural log of t squared plus 1. This does require the chain rule because it's not the natural log of t. So it's the natural log of some other inner function, which I'm referring to as stuff. I have the natural log of stuff, and I want to find the derivative. So the derivative is going to be 1 over the stuff times the derivative of the stuff. So the derivative of t squared plus 1, and the derivative of t squared plus 1 is 2t. So 2t over t squared plus 1. Next, we have the derivative of the natural log of 1 minus x. So we will also need chain rule for this one. It's going to be 1 over the stuff, 1 minus x, times the derivative of the stuff. Okay, that's our chain rule. And the derivative of 1 minus x is negative 1. So our final result, the derivative of natural log of 1 minus x is equal to negative 1 over 1 minus x. The derivative of the natural log of pi. So we need to be careful here because pi is a constant and not a variable. So we should use the constant rule to find our derivative here. The natural log of pi is a constant because pi is a constant. So this is just the derivative of a constant, which is 0. There's no real work to show for that one. The natural log of pi is a constant, and so its derivative is 0. For each of the functions below, find the derivative. So this would be a good time to pause the video and try some of these on your own, and then come back to check your answers. We're going to have to use multiple derivative rules for these problems. So the first one, h of x equals x squared ln x, we're going to use the product rule. H prime of x, so it's the derivative of the first, which would be 2x, times the second factor, ln x, plus the first factor, x squared, times the derivative of the second factor, which would be 1 over x. And we can simplify that a bit. So it's 2x ln x plus x, because x squared times 1 over x is just equal to x. Part B, p of t equals the natural log of t over the quantity e to the t plus 1. So here, we're going to use the quotient rule. We need derivative of the top, which is 1 over t, times the bottom, minus the top, times the derivative of the bottom. The derivative of e to the t plus 1 is e to the t. All of that is divided by the bottom, e to the t plus 1 squared. And we could simplify that. I'm not going to worry too much about simplifying, but I think we should probably not have this fraction inside of a fraction. So we can multiply the numerator and denominator by t to clear that fraction there. So if I multiply the numerator by t, I'm going to have to distribute the t to both terms. I would get e to the t plus 1 minus t e to the t ln t. And then in the denominator, if I multiply by t, I get t times the quantity e to the t plus 1 squared. And let's leave it in that form there. Part C, s of y equals the natural log of cosine y plus 2. So we'll use our ln rule, and we will also use our chain rule and our sine cosine rule. So we start with chain rule. We're going to start this one with chain rule. This is our inner function here. So we have the natural log of stuff, where the cosine of y plus 2 is the stuff. So s prime of y equals the derivative of the natural log of stuff is 1 over the stuff times the derivative of the stuff. So the derivative of cosine y plus 2 is negative sine y. And that would be our final answer. Part D, z of x equals the tangent of the natural log of x. So this is also a chain rule problem where the inside function is ln x. So we start by taking the derivative of the outer function, tangent of stuff. Z prime of x, the derivative of tangent stuff is secant squared stuff. Then we have to multiply that by the derivative of the stuff. So we're multiplying that by 1 over x. And finally, m of z is equal to the natural log of the natural log of z. This is also chain rule. The inside function is the natural log of z. The outside function is the natural log of stuff. So to take the derivative, m prime of z equals the derivative of ln stuff is 1 over the stuff, which is what I've highlighted in yellow, times the derivative of the stuff, and the derivative of ln z is 1 over z. So our final answer, 1 over z ln z. I do find it helpful if you have a highlighter or colored pens or pencils to highlight your inside function when you're doing chain rule. It can help you keep track of everything as you go. So let's switch gears now. We looked at a very particular inverse function. Y equals ln x is the inverse of y equals e to the x. And now we're going to look at some of our inverse trig functions. We're just going to focus on the inverse sine function and then the inverse tangent function. So let's start with inverse sine. And we have the inverse of sine here, h of x equals sine inverse of x. And remember that with an inverse, you switch your input and your output. So if I wanted to go back to regular sine of x instead of sine inverse of x, I would just switch the input and the output. And what I mean by that, this is the input, the x, and this is the output, the h of x. So if I switch the places of the input and the output, that would put the x over here on the left, and then it would put the h of x after sin, but because I'm switching the input and the output, this wouldn't be sine inverse anymore, it would be the inverse of sine inverse. And the inverse of sine inverse is just regular sine. So sine h of x. Okay, these are equivalent equations. And what I ultimately want to know is what is the derivative of sine inverse x? So ultimately, I'm trying to figure out what does h prime of x equal? But I don't have a rule yet for taking the derivative of the right-hand side, sine inverse x. I don't know how to do that yet. So what we're going to do is write the equation in this other form, x equals sine of h of x, because I do know how to take the derivative of both sides of that equation. So we'll write our equation as x equals the sine of h of x, and then we'll take the derivative of both sides. So the derivative of x is 1. We're taking the derivative with respect to x, so the derivative is 1. And the derivative of the sine of h of x, we have to use chain rule, is the cosine of h of x times the derivative of h of x. Okay, so you can see the work here that we've just rearranged the terms. So we've got sine of h of x equals x, and from there we're going to take the derivative of both sides. So the derivative of sine of h equals the derivative of x, and the derivative of sine of h of x is the cosine of h of x times h prime of x, right? We've got sine of stuff. So the derivative is cosine stuff times the derivative of the stuff. On the right-hand side, the derivative of x is just 1. And remember the goal is to find h prime of x. So now we want to solve this for h prime of x, or isolate the h prime of x term. So we're going to divide both sides here by the cosine of h of x. Okay, so then we have h prime of x equals 1 over the cosine of h of x. Now we have to figure out what is the cosine of h of x, and that's where this right triangle comes in. If we look at this equation right here, x equals the sine of h of x, that tells us that h of x is an angle, because you always take the sine of an angle. And when you take the sine of an angle, what you get is the ratio of the length of the side of the right triangle opposite that angle to the hypotenuse, right? So we know that h of x is an angle, and that's why I'm labeling this angle as h of x. And we also have here that the sine is equal to, the sine of h is equal to x. And we can think of x as x over 1. And when we write it as x over 1, it's easier to see it as the ratio. We have opposite over hypotenuse. So the side in the right triangle opposite of h is x, and the hypotenuse is 1. And you can see I've labeled those in that way, x and 1. And once we have two sides of a right triangle labeled, we can get the third side using the Pythagorean theorem. So the Pythagorean theorem tells us that the hypotenuse squared is equal to the sum of the lengths of the legs squared. And so the leg is equal to the square root of hypotenuse squared minus the other leg squared, like so. That's the third side of that triangle. And now I can figure out the cosine of h of x because I know the cosine of h is just the adjacent side length over the hypotenuse. And the adjacent side length is the square root of 1 minus x squared over, and the hypotenuse is 1. Okay, so now if we simplify this, we just get h prime of x equals 1 over the square root of 1 minus x squared. And that is our derivative rule for sine inverse x. The derivative of sine inverse x is 1 over the square root of 1 minus x squared. Now, we can also, instead of saying sine inverse x and using this notation, we can also call that arc sine of x. Those mean the same thing, two different notations for the inverse of the sine of x. Now let's do something similar to figure out the derivative of tan inverse x. So we're going to just call tan inverse x equal to something. We're going to call it equal to r of x. And then we're going to rewrite this equation by switching the input and the output. And we know when we switch the input and the output, we get the inverse. And the inverse of tan inverse is just tan. So that gives us x equals tan of r of x. And we'll take the derivative of both sides. So the derivative of tangent r of x, this is tangent stuff right here. The derivative of tangent stuff is secant squared stuff times the derivative of the stuff. And then the derivative of x is equal to 1. Now we're solving for r prime of x because ultimately that's what we want to know. The derivative of tan inverse x is the derivative of r of x. So we want r prime of x. So we'll divide both sides of this equation by secant squared r of x. And the reciprocal of secant is cosine, so I can also say r prime of x equals cosine squared of r of x. And we'll use the right triangle to help us figure out what the cosine of r of x is equal to. So we have r of x as our angle. We're taking the tangent of r, so we know r is the angle. We'll label that just like that. And then the tangent of r is equal to x. And again, if we think of that as x over 1, we get this ratio. And we know tangent is equal to the opposite side length over the adjacent side length. So I'm going to label the side opposite r of x as x, and the side adjacent to r of x as 1. And now using the Pythagorean theorem, we can get the hypotenuse. The hypotenuse is the square root of leg squared plus leg squared. Now I can read the cosine of r of x, because the cosine of r of x is the adjacent side length over the hypotenuse. So r prime of x equals 1 over the square root of 1 plus x squared, but don't forget we have to square that. We have to square the cosine of r. And when we square that, we get 1 over 1 plus x squared. That is our formula for the derivative of tan inverse x. And we can write that as tan inverse x like so, or we can say arc tan x. So the derivative of tan inverse x, or the derivative of arc tan x, is equal to 1 over 1 plus x squared. In summary, here are those two derivative rules. So you're going to want to memorize these two rules because, as you saw, it took us quite a lot of work to derive the formula for the derivative. The derivative of sine inverse x, or arc sine x, is 1 over the square root of 1 minus x squared, and the derivative of tan inverse x, or arc tan x, is 1 over 1 plus x squared. So let's practice taking some derivatives. Evaluate m prime of 2 if m of x equals f of x cubed. So this is not x cubed. This is f of x cubed, and so we need the chain rule to take this derivative. This is stuff cubed. Let's highlight the inner function. That's the stuff that I've highlighted in yellow, f of x. So the derivative of stuff cubed is 3 times the stuff squared, that's power rule, times the derivative of the stuff. And the derivative of f of x is f prime of x. So now we know m prime of x. To get m prime of 2, we simply substitute 2 in for x. So it would be 3 times f of 2 squared times f prime of 2. And we'll read those values from the table. F of 2 is -1. -1 squared is 1, times 3 is 3. F prime of 2 is 6. 3 times 6 is 18. Okay, number 2, evaluate g prime of 3 if g of x equals arctan of f of x. This isn't arctan of x, this is arctan of f of x. So also chain rule required here. Arctan of stuff. So let's highlight the stuff. F of x is once again the stuff, the inner function. So g prime of x is the derivative of arctan of stuff. And the derivative of arctan stuff is 1 over 1 plus stuff squared times the derivative of the stuff. So g prime of 3 would be 1 over 1 plus f of 3 squared times f prime of 3. And let's read those values from the table. So 1 over 1 plus. F of 3 is 2, and we need to square that to get 4. 1 over 1 plus 4, so 1/5 times f prime of 3 is 4. 1/5 times 4 is 4/5. Determine the derivative for each of the following. Again, we're going to be using multiple derivative rules here. H of z equals arcsine of 5z plus arctan of 4 minus z. So we'll use our arcsine rule and our arctan rule and our chain rule and our constant multiple rule. So h prime of z equals the derivative of arcsine stuff, 1 over the square root of 1 minus stuff squared times derivative of the stuff, which would be 5. Plus, this is next term is arctan of stuff. There's the stuff. There was the stuff for the first term. Okay, so the derivative of arctan stuff, 1 over 1 plus stuff squared times the derivative of the stuff, and the derivative of the stuff is just -1. We're taking the derivative with respect to z this time, and z is our variable. So I'm not going to worry about simplifying that too much. I mean, we could write 5 over the square root of 1 minus, if you wanted to square the 5z, you'd get 25z squared. And then the 1 times the -1 is going to make that -1 over, and I'm not going to simplify this denominator any further. I think that looks good. The next one, f of x equals x cubed arctan x plus e to the x ln x. So we're going to use a combination of product rule, power rule, the arctan rule, the exponential rule, and the natural log rule. We've got a lot of rules there. F prime of x equals, so we start with product rule for this first term. And for product rule, we're doing derivative of the first factor times the second factor plus the first factor times the derivative of the second factor. And derivative of arctan is 1 over 1 plus x squared. Okay, so that's the derivative of the first term in f of x. The derivative of the next term also requires product rule. So derivative of the first times the second plus the first times the derivative of the second, and the derivative of the second would be 1 over x. Okay, so we're going to leave our answer just like that. The next one, p of t equals 2 to the power t arc sine t. This one also is going to require us to use several different derivative rules. We need our exponential rule. We have 2 to the power stuff. That's our main outside function, 2 to the power stuff. And then within that exponent, we have product. So we're going to use product rule and the arc sine rule and the power rule. So p prime of t. And we're using chain rule. So the outer function is 2 to the power stuff. The derivative is going to be 2 to the power stuff times the natural log of 2 times the derivative of the stuff. And now that's a lot to keep straight, so I'm going to just write down the work that I still need to do. T arc sine t, I need to take the derivative of that. All right, so it's 2 to the power t arc sine t times the natural log of 2. I don't know the best way to write that. Okay, and then times, for the derivative of t arc sine t, we're going to use the product rule. So its derivative of the first factor is just 1 times the second factor plus t times the derivative of the second factor. And so now I need the derivative of arc sine t. The derivative of arc sine t is 1 over the square root of 1 minus t squared. Now we're going to look at how to find the derivative of an inverse function in general. So not as for a specific function like ln x or arc sine x or arc tan x, but in general, how do we find the derivative of an inverse function? Let g of x equal f inverse of x. So we're just naming our inverse function. We can call it f inverse of x. We're also going to call it g of x. Okay, so those two mean the same thing. So we have an equation now with two sides, a left-hand side and a right-hand side. And we know that if we switch the input and the output, we get the inverse of the function that we were working with. So with f inverse of x, we would say x is the input and g of x is the output. And so if we switch those, and in the parentheses here, I put the g of x, and over here on the left, I put the x. When I switch the input and the output, I get the inverse of the function I was working with. So the inverse of f inverse. What's the inverse of f inverse? Well, f inverse inverse is just equal to f. So that gives me f of g of x equals x. Those are equivalent equations. Okay, so we're going to start with that right here. F of g of x equals x. And the reason we're writing it in this form is because we know how to take the derivative in this form. What we're trying to figure out is how do we take the derivative when it's in this form, f inverse of x. Okay, so we're going to work with this equation and take the derivative of both sides. Well, on the left, if we're going to take the derivative of f of g of x, we're going to use the chain rule. And that's, for the chain rule here, the inside function is the g of x. So we start by taking the derivative of the outside function, f of stuff, which is just f prime of the stuff, times the derivative of the stuff, which is g prime of x. Right? And that's equal to the derivative of x, which is just 1. Now our goal is to find the derivative of this. And so that means our goal is to find g prime of x. What is g prime of x? So now that gives us sort of where to go from here. We're trying to solve for g prime of x. So I'm going to divide both sides by f prime of g of x. And I know from the beginning that g of x can also be rewritten as f inverse of x. So let's make that substitution. G prime of x equals 1 over f prime of f inverse of x. And really that's, I mean, we could stop right there. That is our formula for the derivative of f inverse. It's 1 over f prime of f inverse of x. So let's look at our definition for derivative of an inverse function. Suppose that f is a differentiable function with inverse g, and that a comma b is a point that lies on the graph of f. So to be clear about that, when we say that the point a comma b is on the graph of f, we're saying that f of a equals b. That's what that means. F of a equals b. And if f of a equals b, then f inverse of b equals a, because when we switch to the inverse function, we switch the input and the output. So the b takes place of the a and vice versa. So if f of a equals b, it must be true that f inverse of b equals a. So we're going to use that later on. Then we can say that f inverse of x prime, or in other words, the derivative of f inverse of x, equals g prime, which equals 1 over f prime of g of x. We saw that a moment ago when we just derived that formula. And if we want to specifically know the derivative of f inverse at b, then it's going to be 1 over f prime of a, because g is the inverse of f. G equals f inverse. So instead of writing right here, instead of writing f inverse of b, I could say g of b, because g is f inverse. G of b equals a. And so right here in this equation, if we're replacing x with b, then g of b can get replaced with just an a. So you see here, it just gets replaced with an a. But honestly, I tend to just think of it as 1 over f prime of, and then f inverse of b. Now to find this, it really is a 3-step process. The first thing you have to do is figure out what is f inverse of b. What does that equal? Because that's the number you're going to have to substitute into f prime. So that's what we want to do first. We figure out what is f inverse of b. What does that equal? Then we're going to, next step, substitute that into f prime of x. And then finally, we take the reciprocal. So our final answer is just 1 over all of that. So here is that 3-step process. The first thing we're going to do is find the value of a. In other words, find f inverse of b. And to do that, we set f of x equal to b. So let's talk about that for a moment, because sometimes people get confused between the a and the b and which should they be using and where should they substitute it. So we have on the graph of f points a comma b. And that means that a is an x value on the graph of f, and the b is a y value on the graph of f. But when we're talking about the inverse, f inverse, we know that we have to switch the input and the output. So on the inverse graph, a comma b is not necessarily a point on that graph, but b comma a is a point on that graph. Okay, so now b is the x value in the inverse function, and a is the y value in the inverse function. Okay, so right here, when you see that you're looking for f inverse prime of b, this means that b is the input. That's what you're putting into, substituting into f inverse, or, well, its derivative. So this is the input value, so it's the x value of f inverse. And if it's the x value of f inverse, that automatically makes it the y value of f. It's a y value of f. Okay, so that's why we set f equal to b, because b is the y value, not the x value. So that's a common mistake that people make right away in step 1, is they want to substitute b into f of x, and that will not work, because b is not an x coordinate in the graph of f of x. It's actually a y coordinate on the graph of f of x. So first step, you let f of x equal the b value and solve. You take that solution and substitute it into f prime of x. That would be step 2. You're going to substitute that into f prime. And then finally, you take the reciprocal. That would be the final step to get your answer. Let's look at some examples. So if f of x equals 3x plus 2, and we want to find the derivative of f inverse at negative 4, the first thing we're going to do is figure out where does f equal negative 4. So we let 3x plus 2 equal negative 4 because, once again, this is a y value of f. It's an x value of f inverse, but that immediately makes it a y value of f. Okay, so we set that equal and we solve. So 3x equals negative 6, x equals negative 2. The next thing we need to do is take negative 2 and substitute it into f prime. And we don't know f prime yet, so we're going to have to get that. F prime of x. So we look right here is f of x. F prime of x equals 3. Now we find f prime of negative 2, the answer we got from step 1. And f prime of negative 2 equals 3. We don't have any x here to substitute negative 2 into, so it's just always equal to 3. And then finally we take the reciprocal. So our final answer is 1/3. Let's look at another example. F of x equals x cubed plus 2. Find f inverse prime of 10. So we have to figure out, step 1, where does f equal 10? Do not substitute 10 in for x. That is a really common mistake, but it will lead you to the wrong answer. You have to set f equal to 10. 10 is a y value of f. It's an x value of f inverse, so it's a y value of f. Okay, so that gives us x cubed equals 8, x equals 2. We take that solution and we substitute it into f prime. F prime of x is the derivative of f of x, so 3x squared, and we find f prime of 2. We get 3 times 4 is 12, and then step 3, take the reciprocal. So the answer is 1/12. Let f equal x cubed plus x. If g equals f inverse x and g of 2 equals 1, find g prime of 2. So g is f inverse. The derivative of f inverse is the derivative of g. So when it says find g prime of 2, it's the same as asking for f inverse prime of 2. So we want to know, where does f equal 2? That's our first step. X cubed plus x equals 2. Now, that one's not easy to solve for x. This is difficult to isolate the x here. But they are giving us a really big clue right here where it says g of 2 equals 1. Remember, that means the same thing as f inverse of 2 equals 1. And that means f of 1 equals 2. And what we're trying to figure out is, where does f equal 2? Well, we know from right here, f of 1 equals 2. So the solution is x equals 1. Now, you might also have been able to just look at that equation and through guess and check figure out that x equals 1. But we have our value, 1, and we're going to substitute that now into f prime of x. So f prime of x is 3x squared plus 1, and then f prime of 1 equals 4. And finally, we take the reciprocal, so our final answer, 1/4. Use the table to find f inverse prime of 3. So we have to know the 3 steps in order to do this. First step, where does f equal 3? So here's f. Where does it equal 3? It equals 3 right here when x equals 1. And now we take the x value of 1 and we substitute that into f prime, giving us 2. And then finally, we take the reciprocal, 1/2. Find g inverse prime of negative 2. So step 1, where does g equal negative 2? So here's g. Where does it equal negative 2? Right here, when x equals 1. Now substitute that into g prime. So g prime of 1 equals 1, and then take the reciprocal. The reciprocal of 1 is 1. Use the table to find g inverse of 1, then find the equation of the line tangent to the graph of g inverse when x equals 1. So let's start by finding g inverse of 1. And we do that by asking, where does g equal 1? Here's g. Where does it equal 1? Right here when x is 3. So we'll take our 3 and we'll substitute it into g prime. G prime of 3 equals negative 2, and the reciprocal of negative 2 is negative 1/2. So that is g inverse prime of 1. If we want the equation of the line tangent to g inverse, we need two things. Remember how we find the equation of a tangent line? We need g inverse of, and then it's when x equals 1. So g inverse of 1 and g inverse prime of 1. Those are the two things we need. Well, we just found g inverse prime of 1 is equal to negative 1/2. Negative 1/2. Okay, that's our slope. Slope of tangent line. Now we need to get the point of tangent C when x equals 1 by finding g inverse of 1. G inverse of 1 equals, I'm just going to say question mark. Now we can figure this out from the table because we know if we switch the input and the output, so in other words, put the question mark here and the 1 here, then that's the inverse of g inverse, which is just regular g. So g of what equals 1? Look at your table. Here's g. Where does it equal 1? It equals 1 at 3. So that is 3. Okay, that gives us our point of tangency. So 1, 3 is our point of tangency. And now we can write the equation of our tangent line. It's y equals the y coordinate plus the slope times x minus the x coordinate. Okay, last example. Estimate the value of g prime of negative 1. Based on this value, what conclusion can be reached about the graph of g when x equals negative 1? So it says estimate. Right away I sort of notice that word estimate. So we're not going to be able to get it exactly, presumably, but we can get close. The value of g prime of negative 1. Well, we have negative 1 falling somewhere between negative 2 and 0. So we can use a central difference here to approximate the derivative. We will use this x coordinate and this, nope, not that one, sorry, g, y coordinate, right? Because if we're trying to estimate g prime, that's the slope of g, we want to use points on g to estimate the slope of g. So these are the closest two surrounding points. Negative 2, 2, and 0, negative 3. And our central difference, so g prime of negative 1, is approximately, we'll subtract the y values, so we can do negative 3 minus 2 over 0 minus negative 2, or negative 5/2. That's our estimate for the slope. And then what conclusion can we reach about the graph of g when x equals negative 1? Well, since the derivative at x equals negative 1 is negative, according to our estimate, we can assume that the function g is decreasing at that point. So g is decreasing at x equals negative 1 since g prime of negative 1 is less than 0. Okay, that wraps up our lesson on derivatives of inverses. And it wraps up Unit 3, Rules of Differentiation. Thanks for joining today. I'll see you guys next time.